don't know how to prepare for a job, you don't know how to prepare your resume, and you don't know whether you're prepared for the company or not, don't worry. Topment will help you to check out whether you really stand out in the interview or not. Simply, you need to go here and search a thing which you want to have. For example, mock interview, resume review, career guidance, or interview preparation guidance. Hello and welcome to the another video of data structures using Java. In this video, we will be solving a problem called as find the middle element of the linked list. What does a problem says that they will give us one linked list. Assume that they have given us linked list and we have to return the middle element of our linked list. If you observe carefully that we can say that 2 is the middle element of our linked list. So while solving this problem, we will be learning one new technique or new algorithms for approaching this problem, and that is nothing but tortoise and hare problem. Now let's first understand what does exactly this algorithm says that. So what does exactly this algorithm says that we will be using two pointer, first pointer name as a slow and the second pointer is mainly called as a fast. So we will be using the two pointers for traversing the linked list, that is slow, and second one is called as a fast. But there is one catch that we need to understand, and what that catch says that the slow pointer will move by one position whereas the fast pointer will move by two position. But we need to make sure that both the pointers are moving at the same time. It is not like that only slow is moving and afterwards fast will move, or only fast will move and then slow will be moved. No, both the pointers should move at the same time. Now let's check how does it happen. So I told you slow will move by one position, so here it will be a slow, and we told that the fast will move by two positions, so here it will be a fast. Now still, if you observe carefully that the fast is not pointing to a null, fast is pointing to a particular node, which means there are still some number of nodes present in our linked list. So again I will take my slow by one position and I will take my fast by two position. Now if you observe carefully that my fast is already pointing to my last node, which means do I need to traverse to again further? No, because I am already pointing to the last node of the linked list. And at the same time, observe carefully that the slow is pointing to 2, and we discussed that the 2 is the middle node of the linked list, right? So this is how we will be knowing how we can get the middle element of the linked list. Now whatever we have discussed, this is we have discussed for the odd length. Now let's try to understand how does this algorithm will work if we have the even length linked list. So again we have taken one even length linked list and we need to find the middle node. So we will be using the same thing, the first is slow pointer and then we will be using the fast pointer. As we know that slow pointer will move by one position whereas the fast pointer will move by two position. So let's keep on moving it. So slow will move by one position and fast will move by two position. So now again my fast is not pointing to the end of the linked list, which means still my linked list has some number of nodes present in it. So what I will do is again I will move slow by one position whereas I will move the fast by two position. Again if I observe carefully that fast is still pointing to a node, it is not pointing to the end of the node or the null pointer, which means still I can move ahead. So simply I will move my slow by one position whereas I will move my fast by two position. Now observe carefully that my fast is pointing to a null, my fast is pointing to a null, which means I have ended traversing the whole linked list, and at the same time slow is pointing to the middle node of the linked list. Slow is pointing to the middle node of the linked list. So there are the two things that we need to make sure that what we have observed from the both example here is that if you observe carefully that in this case the fast is pointing to my last node of the linked list, right? My fast is pointing to the last node of the linked list, and here the length of the linked list is odd, right? My length is odd. So one thing we sure is that if my length of the linked list is odd, my fast will always point to the last node. It will always point to the last node. Whereas if the length of the linked list is even, then my fast will always point to a null. It will always point to a null. So if we have the even length, my then fast will always point to a null. So these are the two conditions that we need to make sure. And whenever my fast either points to a null or either points to the end of the linked list or the last node of the linked list, then simply we can return the slow pointer, because the slow pointer internally says that it is pointing to the middle node of the linked list, right? So I hope so you got us how we can approach to solve this problem. Now let's try to think how we can write the code for this. So we know that with the linked list what they have given us, as we already discussed that whenever we have given a linked list, along with the linked list, they will always give us head pointer, which mainly indicates the start of my linked list. So initially my slow and the fast both will be pointing to head, that is the first node of my linked list. And what I need to make sure is that until unless my fast is not equals to null, and what I need to make sure is that fast of next is not equals to null. Now what does it mean is that this is for odd length, whereas this is for even length. So this is because why we wrote two conditions in while conditions, right? And what we need to do is we need to simply move my slow pointer by one position. I will move my slow by one position, whereas I will simply move my fast by two position. So how can I move it? So simply I will write fast of next. So with the help of this, we are moving our fast pointer by two position. And finally, once I come out of this loop, I will simply return the slow. Which mainly indicates the middle node of the linked list, right? The middle node of the linked list. So this is the simple code which we use to find the middle node of the linked list. Now, what will be the total time complexity for this? If you observe carefully that it might look like, okay, our fast is traversing all the nodes present in my linked list, but no, we are traversing only half of the linked list because my fast is moving by two position. So if I have n nodes, it will move n by 2 times. Therefore, the total time complexity of the code is nothing but n by 2 times. So I hope so you understood the explanation and the approach of the problem. Now let's move on to the IDE and try to write the code for this. So here is a problem. Find the middle node of the linked list. I will provide the problem link in the description. So they have given us the head of the linked list, and what I wrote over here is that if head is equals to null, which means if my linked list is empty, I don't need to do anything. I will simply return as null because my linked list is empty, right? Then it means that there is no nodes present in my linked list. Then I declare the two pointer. First one is called as a slow pointer and then called as a fast pointer, and initially both are pointing to a head, that is the first node of the linked list. And then I wrote this condition if fast is not equal to null, which is for even number of nodes, and then I wrote the fast dot next is not equals to null, which is for odd number of length. And I moved my fast pointer by two position and I moved my slow pointer by one position. And once I come out of this loop, I will simply return the slow, which will be indicating the middle node of the linked list. So just in case if you are new to the channel, do subscribe the channel for more such informative videos. Till then, see you in the next video of the linked list.